Hey guys, here you see a bunch of US currency coins, some older, some still in circulation. But what I want you to do is I want you to take a second and I want you to decide if you could have any two of those coins, which two would you take and why? So today we're looking at solutions to inequalities. I want you to interpret and graph a one variable inequality. I want you to be able to write an inequality from a graph. And I want you to be able to tell me, is a value a solution to an inequality? So looking back at our coins, we have all of these different coins going on here, and you could pick any two. And most likely, I would say that the two you picked, if you knew what was going on, would be this one and this one. The reason why, this is a Kennedy half dollar, this is worth 50 cents, and this is an Eisenhower dollar, which is worth $1, obviously. And so the rest of these, we have a dime that's 5 cents, a nickel, or dime that's 10 cents rather, a nickel that's 5 cents, and a quarter that's 25 cents. And so what we find is that these two coins together are way more valuable than even these four. And so what we might look for is a way to express that mathematically. And in fact, that is what we're looking at. We might say that the value of these coins is less than the value of those coins. And what we've set up there is what's called an inequality. Equations, which we've already talked about, just represent relationships between expressions. And that's the big idea, is that it is relationships that we're talking about. And specifically, they show whatever two expressions we're looking at, the equal sign means they're exactly the same, no difference between them. But if we take any two numbers, let's say 3 and 5, just to have two numbers, there are three options for how this first number can relate to the second one. This first number can be smaller than the second one, it can be equal to the second one, or it can be bigger than the second one. In this case, we know that 3 is smaller than 5. And so what we're looking for, because right now the only thing we have to show a relationship between them is an equal sign, and obviously these two aren't equal, so we need more symbols to show how things are related. And those symbols we have are called inequality symbols. It's just a way to show the relationship between them. Specifically, how do we take two numbers, write them like this, and show that relationship? Inequalities always deal with the relationship between the number on the left to the number on the right. Order matters on these. It's always how does the number on the left compare to the number on the right, and we use these symbols to talk about that. So I've been using 3 and 5. So let's talk about which one of these relational operators are inequality symbols describe this relationship. Well, the number on the left, 3, is smaller than or less than 5. So I would say that 3 is less than 5. If I had a situation where I had a variable, it could be that this, whatever this value is, could be up to equal to, and then we'd use that situation. If they're the same, we'd use this, greater than or equal to, or greater than. Another way of looking at this that is useful to some people is that if you think of this inequality symbol as being a duck's mouth, the duck's mouth always eats the bigger one. So in this case, 5 is bigger than 3. So if we read that left to right, 3 is smaller than 5. Just as with equations, we can use variables in these inequalities. Rather than saying 3 is less than 5, I can say x is less than 5. That's no problem. And then we can talk about solutions, values that replace the variable and make the equation true. And when we were dealing with equations, most of the time we found that there was one solution, but with inequalities, we will almost every time get an infinite number of solutions, which is hard to wrap your mind around, but let's look at this x is less than 5 business. Give me a number that is less than 5. 4. Give me another one. 3. 2, 1, 0, -1. We could literally go on forever. There are an infinite number of numbers I can replace x with that will make this statement true. Every single number smaller than 5 makes this statement true. And so I get a whole bunch of solutions. So let's check this out, and let's see if we can get this, I don't know, in context with what we were doing with equations. So example 1 asks us, is 5 a solution of x plus 2 is less than 3? Remember, the duck's mouth eats the bigger one. So x plus 2 is smaller than 3. I want to know, is 5 a solution? So what I will do is I will replace x with that 5 and then work out the resulting expressions, evaluate them, get them down to numbers, and see if this is true. So 5 plus 2 is 7, and now my statement reads 7 is less than 3. Well, that's just not true. 7 is bigger than 3. We know this. And so this value makes the statement not true. So we would say 5 is not a solution. Remember, solutions make the statement true. This made the statement untrue, so it's not a solution. How about this one? Is 4 a solution of 8 is greater than or equal to 3x minus 4? Well, I do the same thing. I'm just going to replace my variable with that value and now evaluate both sides of the inequality. 3 times 4 is 12, and 12 minus 4 is 8. So the question, is 8 greater than or equal to 8? Well, it's not bigger than 8, but it is equal to 8, and both of those are options. So what happens is that 4 is a solution because this is a true statement. 8 is greater than or equal to 8 because it fits under the equals part of the definition. So we would say that 4 is a solution. Now remember, 4 is just one of the solutions. There are a whole mess of other solutions to this inequality, but what we can say for certainty right now is that 4 is one of those solutions. So the question then becomes, how do we explain that there are an infinite number of these solutions if, like, we don't want to one at a time those. It would literally take until the end of the universe to write them all down. So what we do is we draw them as graphs on a number line. And we're going to look first at the graph of x is less than or equal to 4. So here's what we do. We take our inequality that we're looking at, and you can see it right up here. X is greater than or equal to, or less than or equal to, 4. So here's what I'm going to do. First, I'm going to draw a circle around the number 4, which is what I'm comparing my variable to. And when I draw that circle, I've automatically divided my graph into 3 portions. This portion of the graph that I'm waving at right here with my cursor, this portion of the graph is greater than 4. This portion over here is less than 4, and the part inside the circle is equal to 4. So now if I look at my inequality, I say x is less than or equal to 4. So the part of the graph I'm interested in is the part that is less than 4, and so I shade that in. So I'm literally just going to color all that in, and I'm going to put an arrow at the end of it to show that it keeps on going forever. But x could also be equal to 4. So I'm going to fill in that circle and make it what we call a closed circle as well. And so now what I've done is I have colored in all the portions of my graph where I can find solutions. So any number that's shaded in is going to be a solution to this. For instance, 3 is shaded in. If I substitute that in, 3 is less than or equal to 4. And so now I've shaded in all my numbers, and I know any number that is in that portion of the number line that is shaded is going to be a solution. So let's try a couple of these. Let's graph x is greater than -2. And notice I've not given you a number line, so you have to draw your own. So we draw a number line, and what we're going to do is we're going to put -2 smack in the middle. Now on a number line, always, when you go to the right, the numbers get bigger. So with negative numbers, that means closer to 0, and then positive numbers farther away. And then over on this side, your numbers get smaller, -3, -4, -5, etc. Now, when I go to graph this, first thing I'm going to do is put a circle around the number I'm comparing it to. Now I have a section that's greater than, less than, and equal to there in the middle. And I want to know which one is part of our solution. Well, our solution is x is greater than -2. That's all the parts where x is bigger than -2. And so I would shade those in. Let's go with a different color just because we can. No reason not to. And so I would shade those values in. Put an arrow on it so that I know it continues on forever. And there we go. I've graphed it. I just put a circle around there, and the only part we're interested in is the part where x is bigger. And so that's the part we shade. Any number in that shaded region now is going to be a solution to that. For example, if I select 0, 0 is in fact greater than -2. So let's go again now with, this time, x is less than -7. So again, I'm going to set up my number line. I'm going to put my -7 smack in the middle. Nobody says I can't. Bigger numbers off to the right. Smaller numbers off to the left. And now that I've set it up, I put my circle around -7. And I want all the numbers that are smaller than that. So I'm now going to shade in. Let me pick a different color there. Let's try a blue. So now I'm going to shade in that whole section of the graph that is less than -7. Put an arrow on there to show it continues on forever. And now all the numbers in that region are solutions. Suppose I take -9, plug it in. -9 is in fact less than -7. We're good to go. Finally, there's this one. And you'll notice there's something very, very different about this one, in that the x is written second instead of first. But our principle is still the same. We're going to use the same information to solve this. So our point of interest is 5. We're going to put a circle around that. And now we want to know the relationship between x and 5. So is x going to be the portion that's bigger, smaller, or equal to 5? Well, if we look, the duck's mouth, if you will, is eating the bigger number, and that's eating 5. That means x is smaller than 5. If we read this properly, we say 5 is greater than x. That means the exact same thing as x is smaller than 5. So the region that we would shade is the region of the graph that is less than, going this way. Now, we can also do this going the opposite direction. I can give you a graph and we can write an inequality for it. So look at this particular graph. The number that is circled, so the number of interest, is between 10 and 12. Well, we know what number comes between 10 and 12. That's going to be 11. And so we know we're comparing our variable to 11. Now look at the region that's shaded in. We've shaded in the region that is less than 11, and so we can say that x is going to be less than 11, but we've also shaded in the region that's equal to 11. And so we can say x is greater than or less than or equal to, rather, 11. So let's look at a couple here. Here we've got 8 circled, so that's our point of interest, and we know we're looking at the relationship between x and that. And the part that's shaded in is everything smaller than 8. So we will say x is less than 8. Remember, the duck's mouth eats the bigger one. We don't have the equal to section shaded in, so we're not going to leave or say less than or equal to. We're just going to leave it right like that. And another one, our circled area of interest is 0. 0 is a number too. We can use it. And now we're just comparing x and 0, x being our set of solutions. And we can see we've shaded in the portion where x is greater than 0, and we've shaded in the portion where x is equal to 0. And so there is our inequality. So to sum things up, inequalities just show relationships between two values. Here I'm looking at the relationship between x, so all the values that x could be, and -2. And the solutions to the inequality are all the numbers that make this statement true. And this symbol here tells us what that relationship is. So in this case, x is all the numbers that are bigger than -2 or equal to -2. And we can look at that on a graph. We put our point of interest on here and we label our graph appropriately. And so we can put a circle around -2, that's our area of interest, and x, all the values we're interested in are the ones bigger than -2 or equal to -2, so we'll fill in that circle as well, and there we have it.